Okay, in this video we're going to talk about solving derivatives using the quotient rule. So the quotient rule states that if you have a function over a function and you want to differentiate, or what you do is you take the numerator, differentiation of the numerator times the denominator by itself, minus the differentiation of the denominator times the numerator over the denominator squared. So basically what you're saying here is that take derivative of this times that minus derivative of that times this over this squared. I'm saying this and that a lot, but I'll show you the difference between the product rule and the quotient rule. Remember the product rule, what you used to do is differentiating the first one times the second one plus, and that's very important, plus the differentiating of the second one times the first one. And that's plus and minus are really important. You know why? Because in the product you can switch. It doesn't matter the order, but in the quotient rule, unfortunately, you have to memorize. You have to do it in this order, so you can't actually switch between them because you've got a minus. So you have to start with differentiating the numerator first times the denominator, minus differentiation of the numerator, the denominator times the numerator. So that's really important. There's actually something funny, yeah? I remember in the class, like when I was at school, there was some girl in the back that used to memorize this by following a song. It's called Low D high minus high D low over low low. And you know what that means? So basically the low and high, the low is the denominator and the high is the numerator. So low is like the denominator and d high is differentiation of the denominator. So low, the numerator, denominator times differentiation of the numerator minus differentiation of the denominator times the numerator over low denominator squared. So it's basically low times low to get it squared. If you find it hard to memorize this, just sing this song: low D high minus high D low over low low. Actually, I kind of like it, but to be honest, I didn't memorize that much because well, I used to do a lot of these, so it was stuck in my head already. But after I know this song, it was funny, but I liked it, and you can actually use it to memorize it. It's up to you. So what I'm going to do now is just going to solve an example of how to find derivatives using the quotient rule. So suppose that we have a function, a y function, equals to x to the power minus 1. That's, by the way, a power. Sorry, it's a little bit too big, power. X to the power minus 1 plus 3x squared over 2x squared. Again, we use the quotient formula, which says, again, one more time, that you take the derivative of the numerator times the denominator minus derivative of the denominator times the numerator over denominator squared. That's exactly what we're going to do here. So dy dx equals to, we take the derivative of the numerator, so x to the power minus 1 would become minus 1, we put it next to the x, so it's going to be minus x, and we subtract 1 from the power, x to the power minus 2, and then differentiation 3x squared would become 2 times 3 is 6x, and now times the denominator, and the denominator here is 2x squared, so we times it 2x squared. So we're done with the first one. Minus, now we switch, we take derivative of that times the numerator. So that's exactly what we're going to do. 2 4x squared. If we take derivative of that, the 2 of the power will multiply with the coefficient, so it becomes 4, and then we subtract 1, it becomes x, so minus 4x times the numerator by itself. Let me just minimize the camera a little bit. So yeah, over what we do is we take the numerator, the denominator, we square it. So 2x squared, if you square it, the square would distribute to the two coefficients. So 2 times 2 is 4, and x squared times x squared is x to the power 4. So now what we do now is just distribute the products together, distribute inside the bracket. So what we left out with the first part here before the minus. We're going to leave the denominator for a bit because the most important or the most complicated bit is the numerator. So 2x squared we distribute inside the bracket, so 2x squared times minus x to the power minus 2. Well, let's do the coefficients first. 2 times minus 1 is minus 2. dy over dx equals 2. Minus 2, and then x squared times x minus 2 or minus squared will cancel each other out, because if we 2 minus 2 is 0, so x to the power 0, so anything to the power 0 is 1, so we're left out with minus 2 only, plus 2x squared times 6x, so 2 times 6 is 12, and then x squared times x is x to the power 3, minus, so 4x times x to the power minus 1, again the 4 would come here, but the x's would cancel each other out. It's just power 1 minus 1, so minus 2 to the power 0, and then 4x minus 4x. Don't forget the minus. A lot of students do that, so please distribute the minus as well. That's really important, because if you get it wrong, it might mess up. Not might, actually, it's gonna definitely mess up the whole solution. So minus 4x times plus 3x, so 4 times 3 is minus 4 times 3 is minus 12, x times x to the power 2 is x cubed, and then don't forget about the denominator itself. Now we do is just add up the like terms. So the like terms here are the constants and the variables to the power 3. Notice here that we got positive 12x3 and negative 12x3. Well, they would cancel each other out, so we're left out with minus 2 minus 4. So minus 2 minus 4 is minus 6 over the denominator by itself, so we're left out with minus 6 over 4x to the power 4. That's a correct answer, but if you can simplify it, that would be better. So we can actually simplify it because you've got 6 and 4, so 2 in common. So over 2 is 2, and 6 over 2 is 3. So we're left out with minus 3 over x to the power 4. That's dy dx. So that's your final answer. So this is just an example of solving using the quotient rule. It might get a little bit tedious, but if you follow the rule, the formula, use the formula and factorize and distribute the brackets, I think you should be fine. But I'll solve a few more examples in the upcoming videos, just to make sure, just to get a hold of it.